Hello everyone. Today we will start with some carbon and its allotropic forms. We are done with the physical and the chemical properties of group 13, group 14 elements, and the compounds related to group 13 elements have also been done, right? So today we will study about carbon and its allotropic form, as well as we will study about some compounds of carbon that are important from our examination point of view, right? So students are requested to drop down their names for attendance purpose. We will be starting in a while. Meanwhile, I'll just check my audio and video. Today we will study about carbon. So we can start now. So carbon and its allotropic forms. We have learned that carbon have many allotropes. Some of them are amorphous in nature and some of them are crystalline in nature, right? So now peculiarity of carbon is what? Basically, carbon has a small size, right? And it has higher electronegativity and higher ionization enthalpy, right? And because of this, and also one property, that is the absence of d orbital, absence of vacant d orbital. So because of three properties, carbon differs from the rest of the elements in some properties, right? So in carbon, if you will see, the electronic configuration is what? Basically 2s to 2p2. That means only s and 3p orbitals are available for bonding, right? That means 1s and 3p orbitals. And we know that one orbital can acquire 2 electrons. So 4 will acquire how many electrons? 8 electrons will be acquired by them, right? So carbon can form maximum of 4 covalent bonds, and it can not expand it octet, right? As we have discussed in the previous session also, that carbon is unable to expand its octet, and therefore it cannot form bond beyond 4, right? Now the third property is that it has the ability to form p pi bonds, and higher atoms or higher elements of this group are not able to form p pi bonds because their orbitals are very large for diffusion, so effective overlap does not take place there. Now carbon has catenation property, as we have already discussed yesterday, that carbon can form long chain compounds with itself, right? So this is known as catenation property, and also it shows p pi formation with itself also, and with other elements like carbon nitrogen and carbon oxygen also, right? Now due to the tetravalency and catenation, carbon gives large number of compounds. For example, CO2 we have, CO we have, right? Graphite we have, or diamond we have, or we can have more compounds related to carbon as well, that we will study in today's session also. Now allotropic forms of carbon can be amorphous and can be crystalline also, right? So crystalline forms are diamond, graphite and fullerenes. These we have to study in detail. So allotropic forms of carbon are of two types. One is crystalline and the second one is amorphous. Now amongst crystalline there are three forms: diamond, graphite and fullerenes. We will study them one by one. Okay. Now come on to diamonds. So in diamond, carbon has sp3 hybridization. That means it is tetrahedrally surrounded by 4 carbon atoms, right? So carbon is sp3 hybridized. First point, carbon has a tetrahedral geometry. Second point, right? Now the carbon-carbon bond length comes out to be 154 picometer, right? That means how much? 154 into 10 raised to the power minus 12 meter is the bond length of carbon and carbon in diamond allotrope, right? So this is the structure of diamond. Here you can see this, and the detailed structure of diamond you will study in class 12th, right, in solid state chapter. So this is a covalent network of carbon where carbon is joined in tetrahedral fashion to other carbons, right? So all the 4 electrons are involved in covalent bond forming, and this system is very rigid. It is very hard. The covalent bond that is formed is very strong, and due to this network, the diamond that is being formed by this lattice is very, very hard in nature. Now here you can see that it is the hardest substance on earth. Therefore, it is used as an abrasive for sharpening hard tools, right? For sharpening basically glass edges, right? Diamond can be used. It can be used in the manufacture of tungsten filaments and for electric light bulbs, right? So diamond, because of its structure, basically it is the hardest substance on the earth. Second one is the graphite. Now, if you consider diamond does not conduct electricity. Diamond does not conduct electricity. Okay. While if you will see graphite conducts electricity. Here, if you will learn about the structure, carbon is forming bond with 3 other carbons and 1 electron is left free, which is delocalized over the whole molecule, and this particular electron from each carbon is responsible for the conduction of electricity, right? So if you talk about the graphite structure, it has a layer structure. For example, this is the first hexagonal layer structure, this is the second hexagonal layer structure, third hexagonal layer structure. You can see here that hexagonal rings are being formed here, right? Now, carbon-carbon bond length is around what? 141.5 picometer, right? Here, if you will see that carbon-carbon bond length is 141.5 picometer, and sp2 hybridization is there as carbon is connected only to 3 carbons itself and the 4th electron is left as it is, right? So, the 4th electron is responsible for the formation of pi bond, and these pi bonds are basically, or these pi electrons are present between the layers here, right? And these are responsible for the conduction of electricity in graphite. This is known as what? Pi stacking. Pi stacking. Okay. Now the distance between 2 layers, if you will see, the distance between 2 layers come out to be 340 picometer. Now, graphite, because it is having a layered structure, therefore what is happening that between the layers can slip off each other, right? So therefore, graphite is also used as a lubricant in machines, right? Where oil cannot be used as a lubricant. Why? Because at higher temperature, it will, because of the higher temperature, the oil will evaporate basically because the boiling point of oil will be reached. But graphite, due to its very high boiling point, it can be used as a lubricant in machines at higher temperatures, right? So graphite is very soft, it is slippery, it can be used as a lubricant. Why? Because it is having a layered structure. And why does it conduct electricity? It conducts electricity because of the 4th electron that is left free, and it is involved in what? Pi stacking. These pi electrons are present between the layers and are responsible for the conduction of electricity, right? Now, what is aquadag? Suspension of graphite and water is known as aquadag, and what is oil dag? Suspension of graphite and oil lubricants is known as what? Oil dag. Now, next you come on to what? Fullerenes, right? So, first we will learn that how fullerenes are prepared. So, when you heat graphite with electric arc in the presence of inert gases. What are inert gases? The 18th group gases, right? Helium, neon, argon, krypton, these are inert gases. So in the presence of inert gases, if you heat graphite in electric arc, the sooty material that is released, right, which is of CN formula, that can be C60 also, C70 also, C350 also, right? So this N can be large number of large number of atoms of carbon. So these are known as what? Fullerenes. They are made up of pure carbon. They are made up of pure carbon, and it is called the pure form of carbon. Why? Because it does not have dangling bonds. It has a smooth structure. Here you can see dangling bond is something like this, right? So it is having a smooth structure with straight bonds. Now fullerenes are cage-like molecules. Here you can see the cage is being formed here, right? And C60 has a shape of a saucer ball. So basically it is known as what? Buckminster fullerene. Because of this, C60 is known as Buckminster fullerenes. Now talking about the structure, it contains 26 membered rings, 26 membered rings and 12 5-membered rings, right? So this is the 6-membered ring that it contains and this is the 5-membered ring that is contained, right? Now in its structure, the 5-membered ring can only fuse with 6-membered ring, while the 6-membered ring can fuse with 5 also and 6 also, right? That means you can have a bond like this. That means 6-membered can be joined with 6-membered also and can be joined with 5-membered also. But the possibility of the fusion of 5-membered and 5-membered is not possible because 5-membered can only connect with 6-membered. Again, I'll repeat that 6-membered can be connected with 5 also, 6 also, but 5-membered will only connect with 6-membered, right? Now, the hybridization of carbon atom is sp2. That means 3 sigma bonds are formed and the remaining electron is delocalized over the whole molecule to make it aromatic in nature, right? So, C60, if you will see that again, it has a graphite type bonding, not exactly, but graphite type bonding. This particular electron will be delocalized over the whole molecule and the other 3 electrons are involved in covalent bond formation with other carbons, right? So this electron, these pi electrons are responsible for the aromatic character of Buckminster fullerene. Yeah, so the ball-shaped molecule has 60 vertices as we are mentioning here C60. So basically it has how many vertices? 60 vertices. However, the bond length is not important from the examination point of view. This is just for the information point of view that CC bond distances are 143.5 picometer and 138.3 picometer respectively, right? So spherical fullerenes are also known as what? Bucky balls. Because they have a ball-like structure, that is why they are known as what? Bucky balls. Now next, now which allotropic form is stable in case of crystalline allotropes of carbon? So graphite is the most stable allotrope thermodynamically, right? And we take delta H of formation, that is enthalpy of formation of graphite is 0 at standard thermodynamic conditions. This you will learn in your thermodynamics or thermochemistry chapter in detail, right? And the formation values of diamond and fullerenes are taken as 1.90 kilojoule per mole and 38.1 kilojoule per mole at standard thermodynamic conditions. So graphite, you need to remember, that is the most stable allotrope amongst the 3. Now amorphous forms of carbon. We are done with the crystalline forms. Now we will deal with the amorphous forms, right? So coal has different forms such as peat, which is 60% carbon, lignite, which is 70% carbon, bituminous, which is 78% carbon, semi-bituminous, which is 83% carbon, and anthracite, which is 90% carbon, right? So the most common variety of coal is what? Bituminous. Coke, again, if you do destructive distillation of coal, you will get what? Coke, which is 80 to 90% carbon, right? So here you can see that heat is being provided to powdered coal, right? And here if you will pass water through it, coal tar will remain as the precipitate and coal gas will be obtained, okay, evolved out. Now next is charcoal or wood charcoal. It is obtained by when you heat wood with with fire, basically with oxygen in presence. Yeah, when you heat wood in absence of air, the product that you get is what? Wood charcoal, because it is made up of wood. So basically it is named as what? Wood charcoal, right? Now, when it is heated with steam, it becomes more activated. So, it is used for removing coloring matters. This is important that it is used for removing coloring matters. Now, charcoal masks are also available, right, nowadays, which are used for the basically purification of your skin, that can remove blackheads and so on. Basically, because charcoal is having a highly adsorption property. Adsorption means that it can absorb molecules over it, right? So that is why charcoal is used for purification also. Okay, and nowadays it is used in skin mask also. Now, next is what? Bone black or animal charcoal. So, it is obtained with destructive distillation of bones in iron retort, right? So, basically, when destructive distillation of bones is carried out in iron retort, the products that are obtained are what? Bone oil or pyridine. So it is also used as an adsorbent. See, one is absorbent and one is adsorbent. As I have explained, I guess in the previous session also, what is the difference between adsorption and absorption? Adsorption is the molecules sit on the surface only, and absorption is that they go into the bulk also, right? So on burning bone black or animal charcoal, it gives what? Bone ash, which is rich in calcium phosphate, and it is also used in the manufacture of phosphorus and phosphoric acid. What is phosphoric acid? H3PO4. So bone black or the animal charcoal is also used in the production of or the manufacture of phosphorus and phosphoric acid. Now, next is the lamp black. When you burn vegetable oils in limited supply of air, the product that you get is what? Lamp black, right? So, it is used in the formation of carbon paper, black paint, printing ink. These contain what? Lamp black. Now, next is carbon black. So, when you heat natural gas in limited supply of air, the product that you get is what? Carbon black. So, it is added to the rubber mixture for making automobile tires. So, the tires that you have in your automobiles basically contain what? Carbon black in it. Now, you answer this question, allotropy is due to. What is allotropy due to? Difference in the number of atoms in the molecules, difference in the arrangement of atom in the molecules, difference in chemical properties, or all of these. What should be the answer? Difference in the number of atom, different in the arrangement, difference in chemical properties, or all of these. See, difference in the arrangement of atoms in the molecules in the crystal gives rise to what? Allotropes, right? As we have already seen that in graphite, in diamond, in Buckminster fullerene, the arrangement of atoms in the molecules was different. Right? In class 12th also you will learn about rhombic sulfur, monoclinic sulfur, that is the allotropes of sulfur. So there the arrangement of atoms differs, right? So allotropy is due to the difference in the arrangement of atoms in the molecules. Now answer this question. P-pi multiple bond is seen in mostly carbon or all carbon family member, tin but not in carbon, boron family and not in carbon family. What should be the answer? P-pi bonding is seen in So p-pi bonding is seen in mostly carbon, because we can see carbon, double bond carbon, carbon nitrogen, triple bond nitrogen, double bond oxygen, right? So p-pi bonding is seen in carbon. Now question is, which one of the following is correct statement of fullerene C60? Correct statement you have to tell me. What should be the answer? All of the facts we have discussed in today's class. See, fullerenes are made by heating of graphite in an electric arc, not in presence of hydrogen, but in presence of noble gases or inert gases. So first one is incorrect. Second one is fullerenes are the only impure form of carbon. That is also incorrect because it is the pure form of carbon. Right? Fourth one, if you see, it contains 26 membered rings and 12 5-membered rings. That is correct because we know that it has 26 membered rings and 12 5-membered rings, right? So fourth option is correct. Now in graphite, electrons are localized on each carbon atom, localized on every third carbon atom, delocalized within the layer, or present in anti-bonding orbital. This also we have discussed now only. What should be the answer? So here, if you will see that in graphite, the pi electrons, as I told you, that they are delocalized within the layer, right? Now next question is, graphite has 2D sheet structure, van der Waals forces between different layers, sp2 carbon linked with other 3 carbon atoms in hexagonal planar structure, and all of these. What should be the answer to this question? So graphite is having a 2D sheet structure also. Here you can see this is a 2D structure. 2D sheets are present here. There are van der Waals forces between the layers. These two layers, the adjacent layers are having van der Waals forces. As I have already explained, the carbon is sp2 hybridized, right? And it is having what? Hexagonal structure. So all of these statements are correct about graphite. Now we will learn about some carbon compounds. See, compounds can be inorganic also and organic also. So we will study about inorganic compounds of carbon. However, the organic compounds of carbon, you have a separate chemistry which is known as what? Organic chemistry. Which is known as what? Organic chemistry. It is based on what? Hydrocarbons, alcohol, amides and different functional groups that you will learn in your organic chemistry chapters. But in organic point of view, we have oxides, metal carbonates and metal bicarbonates. Right? So two important oxides of carbon are what? Carbon monoxide, which is very toxic, and carbon dioxide. Right? So first we will deal about what? Carbon monoxide. So carbon on incomplete combustion, it yields what? Carbon monoxide. Right? On the small scale, if you want to prepare carbon monoxide, you can use formic acid. You dehydrate formic acid because concentrated H2SO4 is a dehydrating agent. So if you remove water from HCOH, you will get what? Carbon monoxide. Right? So at 373 Kelvin, in the presence of concentrated H2SO4, formic acid, or it is also known as what? Methanoic acid, dehydrates to give what? Carbon monoxide. Now, carbon monoxide on commercial scale, it can be produced as a water gas. So, CO plus H2 is known as what? Water gas, and the same gas is known as what? Synthesis gas. It is called as synthesis gas. Why? Because, or it is also known as producer gas basically, because this gas can be used for the synthesis of many compounds like CH3OH, which is methanol, right? So that is why the name synthesis gas or producer gas is given to it. Now, carbon in the presence of water at 473 to 1200 Kelvin, it will give you what? Water gas, which is a mixture of carbon monoxide and hydrogen, right? So when air is used instead of steam, here we are using what? Steam, that is water vapors, right? When we use air, so we know that air has a 71% quantity of nitrogen, 21% quantity of oxygen, and so on with other gases also. So here, if you will heat carbon with the air, right, that is, then you will get the mixture of carbon monoxide plus nitrogen gas also, which is known as what? Producer gas, right? So carbon monoxide in water gas or producer gas can undergo further combustion, forming carbon dioxide with the liberation of heat. So this you need to remember. See, carbon plus steam, if you will give, that will give you what? Water gas, that is CO plus H2. Now carbon in the presence of oxygen and nitrogen, that is when you will heat it in the presence of air, that will give you what? CO plus N2. Right? Now this carbon monoxide gas, which is there in water gas as well as producer gas, it can undergo further combustion, that is complete combustion of carbon then will take place, and it will form what? CO2. And this reaction is exothermic in nature because a lot of heat is evolved in this reaction. Now carbon monoxide is colorless, odorless and almost water insoluble gas. It acts as a powerful reducing agent. Right? Here you can see that Fe2O3, first oxygen was there with iron, and now the reduction of iron has been taken place by carbon monoxide. It has gained one oxygen, so it has self-oxidized itself and reduced the iron. Here also zinc, if you will take, it will remove oxygen from zinc, that means it will reduce zinc, forming zinc from zinc oxide, and it will oxidize itself to what? CO2, right? Now it reduces almost metal oxides, but it is unable to reduce what? Alkali and alkaline earth metals and aluminium and a few transition metals. Details you will study in your class 12 chapter, which is metallurgy. Right? So remember that aluminium oxide cannot be reduced by carbon monoxide. Now in CO molecule, there are 1 sigma and 2 pi bonds. Here if you will draw it, basically see what is happening here. C double bond O is there, and a lone pair from oxygen is making a dative bond towards carbon, right? So this is the actual structure of carbon monoxide, which contains what? 1 sigma plus 2 pi, right? Now here it has lone pair on oxygen also, and it has lone pair on carbon also, right? So what can happen here is that it can behave as a donor atom, right? It can behave as a donor molecule, sorry, not atom. It can behave as a donor molecule and can form metal carbonyl. So metal accept electron density from carbonyl and forms what? Metal carbonyl complex. And this you will deal with them in your coordination chemistry chapter in class 12th, right? Now the use of these metal carbonyl complex is basically in nickel, in metallurgy of nickel, or you can say in purification of nickel, which is the Mons process. It is a very famous process. So nickel plus 4 carbon monoxide molecules are taken. It will give you a complex that is nickel carbonyl 4, and then when you will heat it, you will get what? Pure nickel here. You were using here what? Impure nickel, right? And what you are getting here is pure nickel. Now carbon monoxide, as I have explained it yesterday also, so carbon monoxide almost has 300 times more complexing ability than that of oxygen with hemoglobin, right? So hemoglobin carbon dioxide bond is more, sorry, carbon monoxide bond is more stable than that of hemoglobin oxygen, right? So when you inhale carbon monoxide gas, or there is some amount of carbon monoxide gas that is present in your body, hemoglobin will bind to it, right? Rather than that of binding with oxygen, it will bind with what? Carbon monoxide, and will form a stable complex. Now this will lead to the deficiency of oxygen in your blood. Why? Because hemoglobin was supposed to carry what? Oxygen, but now it is carrying what? Carbon monoxide, right? So oxygen cannot be carried around all the body due to the more binding efficiency of carbon monoxide with hemoglobin, and ultimately that will result to death, right? So carbon monoxide is so toxic in nature. This is the hemoglobin structure, right? Which has iron as the metal atom, and this is known as what? Heme group. This rings are known as what? This particular cage-like structure is known as what? Heme. Now coming on to the other oxide, that is what? Carbon dioxide. So it is prepared by complete combustion of carbon and hydrocarbons, right? So carbon plus oxygen will give you what? CO2 when you are doing what? Complete combustion. But when you will do incomplete combustion, then you will obtain what? Carbon monoxide. Now methane also, or any hydrocarbon you will take and combust it with oxygen, you will get what? Carbon dioxide plus water. Right? In laboratory, you can prepare it from calcium carbonate. You treat calcium carbonate with HCl. That will give you what? Calcium chloride plus CO2 from CO3 and plus water. Right? So on commercial scale, it is produced by heating limestone, and also in laboratory, you can prepare carbon dioxide by treating calcium carbonate with aqueous HCl. Now in CO2 molecule, if you will see, it is sp hybridized, as we have learnt in chemical bonding, right? So it is forming p pi bond. Here you can see that carbon is also having a p orbital here, oxygen will also have a p orbital here, and they will do a lateral overlap, resulting into the formation of a pi bond. So this is known as what? 2p bonding, 2p pi bonding, because both use their 2p orbitals for bonding. For pi bonding, they are using what? 2p orbitals. That is why this kind of bond is known as what? 2p pi bonding, right? Talking about the dipole moment, again from the understanding of chemical bonding chapter. So oxygen electronegativity is more than that of carbon, so it will pull electron towards its dipole, will have a direction like this. For this bond also, it will have a direction like this, and these two dipoles will cancel each other, and therefore this whole molecule is having what? No dipole moment, right? So these are the resonating structures. This can be somewhat like this. Oxygen will donate lone pair here, and this double bond will become negative here. Or you can have vice versa also, that this oxygen will donate and this negative charge will come over this oxygen, right? Resonating structures, however, you will deal with them in detail in organic chemistry, and some part of it I think you may have learnt in your chemical bonding chapter also. Okay. However, drawing the resonating structures, you will be able to draw the resonating structures after you will study the basics of organic chemistry, right? Now, carbon dioxide is a colorless and a odorless gas. It is a colorless and a odorless gas, and it has low solubility in water. It is used in carbonated drinks like Coca-Cola and so on, Mirinda, Fanta. These all contain what? Carbon dioxide, right? With water, it forms what? Carbonic acid, H2CO3, which is a dibasic acid. Why it is a dibasic acid? Because first time it will release 1H plus, H2CO3 will form what? 1H plus it will release and form what? HCO3 negative. Then again, this HCO3 negative will lose 1H plus and form what? CO3 2 minus. So this is what? Bicarbonate, and this is what? Carbonate. So 2H plus it can donate. That is why it is known as what? Dibasic acid. Now H2CO3 or bicarbonate, you will learn in your bio class in detail that it helps as a buffer system to maintain the pH of the blood between 7.26 to 7.42. Now, what is a buffer and how does a buffer act? What is common ion effect? That you will learn in your ionic equilibrium chapter. I'll just give you an idea that what is a buffer. Buffer, the main action of buffer is to resist the change of pH on addition of small amount of acid or base. For example, let us say I am taking a solution here, right? Let us say the pH of this solution is 3. Now, when I am adding a small amount of base, obviously it will change its pH, right? It will increase its pH. So, to basically maintain this pH equals to 3, we add buffer to it, or we make buffer of this solution, right? Now, this will be able to keep up the pH equals to 3 on addition of small amount of base or small amount of acid will not affect its pH now, because it is a buffer solution, right? So to maintain the pH of blood between 7.26 to 7.42, we use a buffer, which is what? Carbonic acid buffer. Now, carbon dioxide in the solid form, it is known as what? Dry ice, and dry ice is used as a refrigerant for ice creams also, or for keeping fishes also. Here you can see, right? And it is a non-supporter of combustion, right? So basically we have fire extinguishers which have CO2. So they cut the supply of oxygen, and therefore the fire can be prevented from spreading, right? So NaHCO3, sodium bicarbonate, releases what? Na2CO3 plus carbon dioxide gas. Now this carbon dioxide gas cuts the supply of oxygen, which is very much necessary for the fire to burn, right? And if no supply of oxygen will be there, or the oxygen supply will be cut, then the fire will extinguish itself, right? And CO2 is also used to manufacture urea. What is urea? NH2, C double bond O, NH2. This is what the formula for urea. Now, this is the carbon cycle. See, from CO2, from atmosphere, CO2 is removed by the process which is known as what? Photosynthesis, right? So, plants use carbon dioxide and water in the presence of light, and obviously a green pigment, that is chlorophyll. It forms its food, that is glucose, right? And releases what? Oxygen. So, one way of consumption of carbon dioxide is by plants, because they do photosynthesis by taking CO2 from the atmosphere, right? Now, what is happening here is that animal respiration, because we respire out what? Carbon dioxide. We respire in oxygen, and we respire out what? Carbon dioxide, right? Transportation and factory emissions also are adding the carbon dioxide percentage in the atmosphere. Organic carbon also, it is adding carbon dioxide percentage in the atmosphere, right? So the intake of carbon dioxide in the atmosphere is becoming more and more rather than consumption, right? Here you can see that by 4 processes, 1, 2, 3, 4, in fact 5 processes, you can have carbon dioxide in atmosphere, right? But only one process is involved where the consumption of carbon dioxide is taking place by photosynthesis, right? So as we are cutting more and more trees, so the carbon dioxide percentage in the atmosphere is also increasing. Or we can also say that combustion of fossil fuels, decomposition of limestone, etc., are also increasing the amount of carbon dioxide in the air. Now, due to this excess of carbon dioxide, or the increasing level of carbon dioxide in atmosphere, this leads to greenhouse effect. And because of this greenhouse effect, because this CO2 gas captures what? Radiations which are given out by sun, right? So these incoming solar radiations are absorbed in atmosphere by greenhouse gases, and this eventually lead to what? Rise of temperature of the atmosphere, right? So the floods which are basically taking place, or the heavy rains without the season, right? Without the monsoon, we are having rains on earth at some part of the earth. This is all because due to the greenhouse effect. And what is the greenhouse effect due to? Because of the increase in amount of carbon dioxide. The carbon dioxide traps the solar radiations which is incoming from the sun, and therefore the temperature of the earth is increasing day by day. Now, carbogen is what? Mixture of oxygen, and 5 to 10% of carbon dioxide is known as what? Carbogen, and it is used for artificial respiration for victims of carbon monoxide poisoning. Let us say that some person is having what? Carbon monoxide poisoning. So, hemoglobin is not able to carry oxygen throughout the body or throughout the blood, right? So for that we use what? Artificial respiration by carbogen, which is a mixture of oxygen and 5 to 10% of carbon dioxide. As we have already discussed, that carbon also has suboxides where the oxygen proportion is less than 1. So here you can see that 3 carbons are having what? 2 oxygens, right? While CO and CO2, if you will see, 1 carbon is having 1 oxygen, 1 carbon is having 2 oxygen. But here you can see that the number of carbons are more than that of oxygen. Therefore, they are known as what? Suboxides. Now coming on to natural gas, what is the composition of natural gas? Methane is 60 to 80%. Hydrocarbons, which are the compounds of carbon and hydrogen, like ethane, methane, propane, butane, and so on, right? So these are what? 2 to 12%. Ethane is 5 to 10%, and propane is what? 3 to 18%. This ethane, propane, I guess you have learnt in your 10th class also. So this is the composition of the natural gas. It is found along with petroleum below the surface of the earth. So it can be used as a fuel, right? So its partial combustion yields what? Carbon black, which we studied that it is the reinforcing agent for rubber, right? Now next is oil gas. So kerosene, if you heat it in the absence of air, that will give you what? Mixture of simple hydrocarbons, right? So its uses it involves what? It is used as a fuel in laboratory in Bunsen burners. I hope if you have visited your chemical laboratory in school, right, or chemistry lab in school, the Bunsen burner, the gas which is used in Bunsen burner is what? Oil gas, right? Basically, which is obtained when you heat kerosene in the absence of air. Now, next is wood gas. Again, destructive distillation of wood will give you what? Wood gas, and it is also used as a fuel. Gas, I hope all of you are familiar with this, right? So its composition is what? Its composition is very important, that you should know that LPG consists of what? Butane and isobutane, and it is known used as what? Domestic fuel, right? Now basically we have strong foul smell, of the gas which is filled in cylinders, right? So we add what? Ethyl mercaptan, and that is C2H5SH. It is added to LPG, so that whether it is leaking or not, right? Sometimes you must have felt at your home also that when the gas is leaking from cylinders, it often has a foul smell, right? So basically, identify the leakage of cylinders which are filled with LPG. We add ethyl mercaptan and thioethanol, which are foul smelling substance. Because LPG itself is a odorless and a colorless gas, right? So its leakage cannot be detected easily, like ethyl mercaptan and thioethanol, because sulfur compounds are relatively foul smelling in nature, right? Sulfur compounds are foul smelling in nature. Even the skunk animal, um, it is known to have a foul smell. It releases some sulfur. Now answer me some questions. The mixture of CO and hydrogen is known as, carbon monoxide and hydrogen mixture is known as what? Water gas or producer gas, water gas or synthesis gas, producer gas or synthesis gas, or producer gas. What should be the answer for this question? So where the oxygen content is basically less than carbon, that is your suboxide. So C3O2 is carbon suboxide. Now next question is, which one of the following properties is the properties of carbon monoxide gas? Which one of the following is properties of carbon monoxide gas? Colorless, odorless, neutral oxide, all of these. So these questions you can take as homework, and we will discuss it in the next class. Which one of the following is properties of carbon monoxide gas? This is the first question. Second is the metal oxide which cannot be reduced to metal by carbon is. Which one of the following metal oxides cannot be reduced to metal by carbon? And the third one is that carbonic acid is a weak tribasic acid or strong dibasic acid. So these are your questions for homework, right? And we will continue in the next class with some compounds of silicon, right? So that's all for today. Happy learning to all.